Okay. Well, I think we're about ready to get started. So I'll say, hello, gang. Welcome to my talk. This is Lessons Learned Building Observability for a Nonprofit. Quick about me. My name is Willard. I use they, them pronouns. I'm a software engineer too at Datadog. I graduated from the Rochester Institute of Technology in 2023. I have hobbies including running and science fiction. And I have about 6 years of experience operating nonprofit infrastructure, 4 in college at Computer Science House, and 2 at the Mesh so far. So to start off, I want to introduce NYC Mesh and who we are and what we do, and talk a little bit about our routing. I promise I will not get too technical. This is just to give you all some context. So first of all, NYC Mesh is a 501c3 organization. We've been around for about 11 years. We're a nonprofit that operates a wireless mesh network in New York City. We try to cover all 5 boroughs. This is the map of our current nodes. And our goal is to provide affordable and equitable internet access to New York. We are community owned and operated. We are almost entirely volunteer run. The people who actually buy into the network are the ones who run it. And we are mostly just like network amateurs doing this in our spare time. So it's pretty cool. We have about 2,500 connected members, dozens of larger network hubs, and 5 super nodes. So we say that our backbone infrastructure, that's how our autonomous system peers with the rest of the internet to provide that internet access to our members. So I want to zoom into this map a little bit and go over a little bit more detail about our network. So if you know anything about networking, you know that you have routers or you have hosts that want to talk to other hosts. There's an IP address, and if you're on a direct connection or on a switch, you can just, if you know the IP address, you can get to that host. If you're not on the same switch, you need a router, and the router will say like, hey, I want to get to this subnet. Well, the router knows, hey, this subnet is over here, so I'm going to send your packets over here, and vice versa, right? So our network is a mesh network, but we operate more on a hub and spoke model. And despite that, each of our nodes sort of knows how to get to every other node. That's where the meshing happens. But the hub and spoke model is important because we have this sort of 3 levels of node. So the red dots you see, those are all just nodes. We call them nodes. They're usually just people's apartment buildings, households, and they have some equipment on their roof that lets them connect to the mesh. The larger light blue circles are hubs, and those are usually larger. They have bigger antennas pushing more data. They're central to like neighborhoods. And then the dark blue dot there, that is a super node. That's a data center. That's where we peer with the internet and have really, really big routers handling a lot of traffic. Another thing to note is that redundancy is key in our network. So you'll see that there's a lot of different connections to every which where. That's really important for that meshing and for that redundancy and that resiliency. So a little bit more detail about how that routing works. We use a routing protocol called OSPF. That stands for Open Shortest Path First. When I say routing protocol, it's like literally like BGP is another common one that people might have heard of. It's just another way to sort of identify routes and then use them and get traffic all around your network. So internally in the mesh, we use OSPF because it is an open standard that is very widely available. Most, if all off-the-shelf hardware you grab out of like Micro Center or Amazon or whatever is going to know how to speak OSPF. So it makes us, it lets us just sort of configure it and throw it up there, and it just works, which is great. It also has this cost-based routing concept, which is really important for that redundancy, because typically you'll have like a really fast link from one node to another or from one node to the internet, and you want to take that one. So you set the weights around the network such that the most nodes opt to take the shorter, lower cost route. However, this has been, this is, first of all, I'll say scalable to thousands of routers. We've got, I think, close to 1,000 routers in our network right now, and we get really good performance. Thing I was going to say was that it adapts quickly to network changes. By this, I mean it has a fast convergence time. So when a node goes down or a node comes up, all the links have to figure themselves out again. And OSPF is really good at doing that. So when you have an antenna that goes down for whatever reason, that link is lost, and you have to go find another route. And OSPF has some good algorithms to do that. Works very well on our network, which is a little chaotic. I don't know if you can see that, but there's an asterisk there. I'll talk about that in a second. It also is an event streaming protocol, so you can set up a software called Bird on a Linux box and actually get like events streamed in from the OSPF network that are like, hey, this route is up, this route is down, this route has changed its cost. You get all that data in real time, which is great for observability. So one fun fact about OSPF is that typically it's used in data center environments where things are very clean and perfect and sterile, and you have all these great fiber optic connections that are like solid and really, really, really awesome and never go down ever. We operate a wireless ISP in New York City. Our network actually never converges. Because routes come up and go down all the time. There's storms, there's wind, there's rain, there's landlords cutting cables. So yeah, there's all kinds of things that can cause those routes to change. So even if there's no traffic from our members, there's always this constant like hum of OSPF activity on our network. Despite that, like I said, it's worked pretty well for us over the last 11 years or so. Usually you get around 50 to 100 megabits per second on your mesh connection, but in some places you can get as much as like 700 or 800 megabits to the internet, and you have wicked fast ping times. So it's really, really good, even despite all of these adversities. To explain this diagram a little bit more, I want to just give a quick example. Let's say that you are node 289, and you're trying to get to the internet. You do that through node 713, and the cheapest cost is through 162, that's 10 plus 9 is 19. But you also have this cool route over here through 499, that's 10 plus 100, 110. Not as good, but it's there if you need it. So let's say this, I'm going to use the mouse. This link goes down here, node 9, or link with the cost of 9 goes down. Well, suddenly 162 can't get to the internet, so you can't get to the internet, except y'all know about 499. So all three of these nodes still have internet because they can route through 499. So that's kind of the idea. So to illustrate what that looks like in the real world, I have some photos. This is what a rooftop node looks like. So there's two pieces of equipment that are very typical for a mesh install. There is an OmniTick, which is that guy right there. That is an omnidirectional Wi-Fi antenna plus a router. So you've got a cable out of that OmniTick down into your apartment, into your own router. That's how you get internet. You also have a Lightbeam Gen 2, that guy right there, that does a point-to-point connection to another node or to another hub or something like that. And then also you can optionally have an additional router, or an additional antenna, excuse me, that will do Wi-Fi to like an area. So you notice there's a park down there. So we have that little antenna right there to broadcast Wi-Fi down to the park for people to use. This is a community network. We try to help the community. That's pretty common throughout the mesh. So once you go from your node, you're going to hit a hub eventually. And these are like faster. Like I said, they have bigger antennas that are usually more expensive and usually use a special like part of the bandwidth, like 60 gigahertz or 24 gigahertz, or I think like 72 gigahertz, a bunch of them. And so these will usually have the larger antennas, and then they'll also have like dedicated routers and maybe a UPS to protect against power outages. And then those will go to super nodes. And these are really cool because they are data centers. We have rack space. We have larger core routers talking to other larger core routers. We are usually leasing like fiber, and we are leasing ports on the core routers that do all of the BGP peering for the autonomous systems of the world and create the internet. And then also, as I'll mention later, you can rack not just routers here, but you can also rack servers. So this is where a lot of our server infrastructure runs, which is really cool. So that's kind of the network. What are some of the risks? I've sort of hinted at some of them, but let's list them out because I think some of them are important to consider. So the first one, and the worst one, is probably weather. Again, we're outside, there's wind, there's rain, and with some of the wavelengths that we use, some of the frequencies we use, they are actually susceptible to this thing called rain fade, where for physics reasons, water interacts with certain parts of the RF spectrum, which is really annoying. So what this means is that during a thunderstorm or when it's sleeting or snowing or even just foggy, a lot of our 60 gigahertz antennas will go down. And that's really bad because those are our fastest antennas. They're usually a gigabit or more of connection, and they're usually in a really important place. So we like to have backup links at those sites to when there is rain. At least we have like a failover that can very quickly decide, okay, the 60 gigahertz is cooked, let's use the 5 gigahertz. That's not as bad. So that's great. Another consideration, power outages. I talked about UPSs. This isn't just the grid is not 100% reliable, but also a lot of our equipment is put into public places like shared rooftops. Things are plugged into, family households. People unplug our routers to plug in vacuums sometimes. That's a consideration. So when you are building a hub it was a node and now it's a hub, you usually have to think about that where it's like, okay, like this is a great building, it's got great line of sight, but we know historically from our data this node goes down a lot. So we have to think about that and be like, what can we do to make this better? Either we give the PoE injectors that actually run the antennas on the roof to some other person in the building who might have a more readily available plug that is not vacuum seeking, or we just give them a UPS or something. There's also hardware failure. So again, outside, not a great place for technology. Seals will leak, plastics will crack, things will fall apart. It just happens. The only thing you can really do is have hot spares ready to install in its place. We also have misconfiguration. We're volunteers. We don't know what we're doing. We sometimes will make a mistake. Somebody will make a mistake and they'll set the cost on a route too low, and suddenly you have the entirety of Brooklyn going through one tiny 5 gigahertz link. Not great, but pretty easy to fix. You also have, unfortunately, vandalism. I mentioned it has happened before where we have landlords who are hostile to the mesh, and they just go up there and cut the cables and don't talk to anybody. And then we have to have a whole like, hey man, what the heck? And then it's a whole thing. So we do have to worry about people messing with our equipment. Luckily, it's not too much of a problem, but like it does happen. So it's a consideration. And again, it's just having spares, having people in the area, having redundancy, all of that. There's also firmware bugs. These are complicated machines, these antennas, and they have complicated firmware doing complicated things. So it's important to stay up to date with the latest Ubiquiti or MikroTik or whatever firmware. Those are our two main vendors, so I mentioned them by name. They're great. And sometimes they have bugs, so you just have to make sure that your stuff is up to date. And then finally, the most weird one is wildlife. Birds make nests in places. Sometimes those places are inconvenient, such as the mounting points. They also defecate a lot on your equipment, which is not great, but you know. So anyway, all of this stuff can cause outages, it can cause slowness, and it can cause flapping. And quick sidebar, what flapping is, by that I mean a route will like come up just long enough for everyone to be like, oh, cool, a new route. And then they'll start using it, and then it'll go down. And then it comes up, and then it goes down, and then it comes up, and it goes down. And it just does that over and over again in a pattern such that it severely harms the speed of the network, because things are just unable to cope and just say, okay, that route is cooked, let's just not use it. It just comes up and down over and over again. So I mentioned that by name because it's a very annoying issue to both detect and remediate. So that's a big one. So we have all these issues. What do we do about them? You might be surprised to learn that the answer starts with observability. So how do we do that? Well, the first thing is having volunteers who are knowledgeable and friendly and willing to donate their time and effort to make sure all of this stuff works. This is a very large, very complicated system, and if it weren't for the like dozens of dedicated people who give their time out of work to go and help us, it wouldn't exist. So good volunteers, very essential. Supporting them, thorough documentation. Write stuff down and make it available to people. That way, when there are issues, a lot of people will know how to fix those issues. Makes sense. The next thing is knowing about the issues. So having good channels through which people can alert is really important. So we have a ticketing system and also a support channel on Slack. Our main mode of communication is Slack, by the way. That will be important later. And that way people can just get in touch with us when something is broken, if they have slow speeds or if they find themselves without internet. So that's important. Robots are great. If you have a way to automatically see like, hey, this link is down, send a push notification. That's really useful. Diagnostic tools are also really important. Dashboards, data viz on OSPF is really useful for us, like I mentioned. And also config tools and knowing how to use them. So here are some of the tools we use. This stack has grown organically over a number of years. And we're still tweaking it, we're still changing it, but we've gotten to a place where, at least I like to think, we're pretty good at noticing issues and then resolving issues. So what does that look like? How did we get here? And what did we learn? So I joined the mesh in 2023, so I'll start there. In 2023, our alerting looked something like this. People would just kind of be like, oh man, my internet's down, and then ping in Slack. We didn't have any robots yelling at us when things broke, which wasn't great. The other way, of course, I mentioned email. We use OS Ticket. It's a piece of software, for sure. Yeah, these are our two main channels of getting alerted to when things are down, when there are problems. If a hub is down, we'll get a lot of emails. So that's great. Here's what the flow kind of looks like. So you have something happen, right? You have your members ping you in the support channel or send you an email. When they email us, a volunteer has to like go and repost the message because nobody checks the email except a couple of people. So usually it's like, oh, hey, somebody emailed us that something's down. Uh-oh. Another volunteer has to go in there and do a bunch of diagnostics on this, that, and the other router. Everything between the member who's having problems and the intranet, which can be 5 to 10 hops sometimes. Usually it's only 2 or 3, but even that is still a lot when you have to go and run speed tests on this or that node, pull the configs, make sure nothing is misconfigured, check the logs, maybe reboot the device. It's a lot of work to do over and over and over again on 2 or 3 or more routers. Then you maybe tweak some settings and you wait. And maybe the member says, hey, I can watch my Netflix. I'm getting the speeds I'm expecting. Everything's great. Until next time. Or maybe it doesn't work and you have to start all over. And that kind of sucks. Fortunately, the mesh, even at this time and before, had some tools to deal with this. The first one that I'll mention is a vendor-specific one known as UISP. This is a great piece of technology for us because it works great for Ubiquiti devices. You can visualize your entire network. There's a lot of great logical visualization tools, and then you can drill down into individual devices and see stats about signal strength. You can get historical metrics, which is really cool because you can actually see hey, there was rain on Tuesday. I didn't even notice when you're looking at a 60 gigahertz antenna. You can also do some basic configuration, and if it's a switch or something, you can actually see what ports are plugged into and where the power is coming from and where it's going. Very cool. Here's one of what the logical visualization looks like. It's not great, but if you dig into it, it's fine, I guess. It also will tell you if things are out of date, which is very useful because you can then go in and update things. So that's nice. However, there is an asterisk to this. And for non-Ubiquiti devices, you don't really get a lot of information. You basically just get is it up? Is it not up? And that's it. It also has some very simplistic email alerting, which we do use, but it isn't very good because it's just hey, this thing went down. That's it. So it's not great, and it just goes to an email and then a channel that nobody looks at. So anyway, how do we fix these problems? Well, we have Grafana as well. Grafana is great because it's where we monitor the rest of our network, not just Ubiquiti. We have dashboards for our OmniTix and all of our MikroTix stuff that's not compatible with the UISP software. So with that, we can build some cool dashboards and see stats that are coming from SNMP. We've got SNMP traps configured to ingest that into an influx DB, and then we visualize that with Grafana. So that's great. It can show us throughput and signal strength and stuff like that. And then we can do cool things like rain fade detection. So this is very cool, except that one issue with it is that it's manually configured. So it's like for every single like important antenna, you have to like go into Grafana and be like, hi, this antenna exists. Please get SNMP from it. Can be a little tedious. But you do get cool things. Well, you don't get alerting. That's another issue. But you do get cool things like this where you can see thunderstorm happened right there when suddenly there was no traffic on this AF24. Not great, but now you can see it. Next thing I'll mention, this is a custom thing. I mentioned that we can ingest OSPF updates. So we have some custom software that is open source, by the way, if you want to look at it. We can look at our OSPF data and see like, hey, here's the current status of the mesh. Here are all the nodes. Here's how they all talk to each other. It's very cool. You can also simulate like impact during an incident. So like you're like, hey, let's say that this node goes down or this link goes down. What does that do to our traffic? Who doesn't have internet? Who is rerouted? And where? So when somebody's having an issue, you can actually go in. You can see like, all right, I can see that like this morning you were going through like 5151 to 713 and then to the internet. Now 5151 is just gone. So yeah, you're going through like a much weaker antenna and you're gonna see some worse traffic until we can go send somebody out there and figure out what's wrong. So that's a really useful tool for us. Another one that's useful is Uptime Kuma. This is where we start getting into the alerting problem. So this is a great tool if you don't know about it. You just deploy it on a box and it does like simple like pings to like web services and equipment. I think it also has like gRPC support and a couple of other things. We don't really use it, but it is there. Very cool open source tool, very easy to set up and configure. And then yeah, it can also send you alerts as well. So we have a channel set up that's like monitoring some of our web services like UISP, and it'll be like, hey, this is down because XYZ reason. Well, actually it won't do that. It'll just sort of tell us that it's down. So again, it's like we got alerting, but we don't quite have rich alerting yet. So that's a bit of a problem. But that's okay, because this, like knowing, hey, this Omni went down, this router is down, is still useful, and having that like in Slack and being able to customize it beyond the like constraints of UISP, and not to mention for more than just Ubiquiti equipment, is still very useful. So I joined the mesh in 2023, and I saw all of this, and I was like, okay, how can I help? Like I'm a bright-eyed young guy out of college, and I want to do networking stuff. I don't know the first thing about networking. I don't know the first thing about the mesh, but I do know about DevOps. So what can we do? And somebody told me, hey, let's try setting up Zabbix, because Zabbix has better alerting, and it has SNMP trap capabilities, so you can really easily just like set up SNMP traps and have your alerting. And I did that. And I got some pretty good results. So I managed to build some custom software on top of Zabbix that gave me some rich alerting on the SNMP traps. And then I also scraped the UISP API and managed to get like real-time metrics for all of our antennas and some of our routers, and able to get this nice bird's eye view of our network. And then I was able to set up triggers on all of that data to say like, hey, this antenna at this node is having low signal, and I noticed that it's like gone down and come up like 5 times in the last minute. This thing is probably flapping. Something is probably wrong. I can do that nice rich alerting for like all of our antennas. Problem solved, right? Like we've done it. We've reached the finals. It's great. One problem with this was that it was very difficult and time-consuming to set up. This took me months to figure out. That might have just been due to inexperience, but it took volunteer time. I worked a full-time job. I came home. I yelled at the UISP API for like 3 hours. So that was not great. And ultimately, this ended up not being feasible to maintain for reasons I will talk about right now, actually. So the reason this was not feasible to maintain was because I was spending all this time on this monitoring software, but we wanted to do more stuff. We wanted to do more software stuff because it's not just network monitoring that is required to run the mesh. You also need some web services. Well, how do we do that? That's a like 10-year-old HPE server with like 4 gigs of RAM shoved into an elevator room in one of our hubs. That's the best server we have. Not so great. There's other stuff in the mesh, but it's like 15-plus-year-old Dell hardware running bespoke VMs with failing drives. Some of these VMs people haven't logged into in years. Besides that, there's also services hosted on like people's personal cloud accounts, which like, thanks so much for giving me AWS credits to like play with, but also you really shouldn't be doing that for a lot of reasons that are kind of outside the scope of this talk. So I'll skip that. But yeah, a lot of manual configuration, not great hardware. What can we do? Well, work with what we have and build only what is obvious. So all of this stuff we built over learning about how people react to outages and how our members will let us know. A lot of them aren't technical, right? They don't work in tech and they don't care about networking, and they're just like, hey, my Wi-Fi is broken. Great, okay, why? Don't know. So we have to go into our network and peel back those layers. And so what we did was we built tools with the tools that we had, those machines shoved in closets in elevator rooms, and we built tools that would run on those to get us closer to like, hey, I'm not having internet because this hub is down because this antenna went out, so everything's going through this small link in Brooklyn, right? We're getting there, and what we did was we built what we could with what we had, and we focused very closely on meeting that goal. Why didn't we just buy cloud stuff? Why didn't we just get some EC2 instances to like host this stuff better? Couple reasons. I'll get more into one of them right now, but one of them in a minute. And that's CapEx versus OpEx. We're a nonprofit, and I imagine that if you're in this talk, maybe you are also involved in a nonprofit or a small business or whatever. You don't have, the point is, you don't have a large budget, and maybe your income isn't guaranteed month to month, year to year, whatever. So you don't want to pay for AWS because that's operational expense. That is a recurring cost that you might not be able to pay in 2 months, right? So what we did was we worked with what we had. We worked with one-time purchases. Like, hey, yeah, I can spend $100 and get some more RAM for this box. That's a one-time purchase, right? And now we just have more RAM. Awesome. So we really tried to optimize for CapEx because it was what was allowed, right? It was what the org wanted to do. So we worked within those constraints and got that first step. So that's my first lesson: is build only what is obvious. Moving along to 2024, I want to change gears a little bit and talk more about that side that I mentioned, where there's not just the networking part of mesh, there's also like some ops that we have to do. Excuse me. We were looking at doing sort of bigger, more complex software projects. Those bigger software projects would require maturing our tech stack, more automation, trying to deploy things with Terraform and Helm, and we also started dipping our toes into Kubernetes. This required some changes. First of all, we were going to need some new hardware. And this growing technical scope with these complicated software projects that we haven't really proved out yet meant that we needed to level up our observability game so that we could catch issues early and fix them before they became really big problems that caused the mesh to not be able to operate. What do I mean by operate? Well, here are some of the things that we need in order to actually, operate. First of all, communication. That's solved. We have Slack. We are on a free nonprofit plan. That's great. Thank you so much to Slack for allowing that. That's awesome. Next thing is docs. We currently have a book stack that is very, very dense and very well populated. Again, observability requires people knowing what the hell they're looking at. So we try to keep our docs really up to date. And by the way, it's open source. So if you want to go and look at our docs, you can. There's a link later in the presentation. I'll point it out. Billing. This is something that is we don't want to touch this, so we use Stripe for this. Email, again, email is the devil. We can use Gmail, we can use G Suite, that's fine. Again, nonprofit plan, it's great. File storage, again, Google Drive. Support is OS ticket. We do signups. We're going through a Google form into a Google Sheet for the last 10 years. That's a lot of data. Member management, same thing, Google Sheet. Device management, same thing, Google Sheet. Do you see where this is going? So we looked at this in 2024 and we were like, geez, some of this, we have solutions for all of these. Some of them aren't so great. Oh, and more, sorry. These are the ones that are not great. Docs was actually used to not be Bookstack. It was this like GitHub Pages thing that compiled to Netlify, so every time you wanted to modify the docs, you had to make a pull request. So it didn't really allow people to just put information on our docs. Not great. The other thing was member management and device management. The Google Sheet was big and slow and not searchable, so we decided we needed to change these three things. So we did the new wiki. Here are the links, by the way, if you're curious. Wiki.nycmesh.net for those of you in the back. We have everything on there from OSPF routing theory to how to table for an event. We try to keep them very up to date. If you have any questions, you can join our Slack. There will be a link for that later. But yeah, we really care about open access and open info in the mesh. So all of our code is open source at github.com/nycmesh.net, and our wiki is open for people to look at wiki.nycmesh.net. As for the signups and the member management and the device management, we built a cool thing. We built MeshDB. MeshDB is a Django database for our node and our member data. It's completely self-hosted. There's like a custom signup flow, and this enables a ton of automation because we have an API, something we didn't have with our Google Sheets. So now we can build all that cool automation and build a nice UI for people to work with this data, and our signup experience is better and looks more polished, and it's great, and we don't have to depend on Google as much. That's awesome. But how do we operate this? We've never operated anything like this before, and our hardware at this point still kind of sucks. So we need to be sure that this actually works. But we got to build MeshDB. We can't take this diversion to go and level up all this stuff because we can't justify it because we don't have MeshDB. So we have this bit of a chicken and egg scenario where we want to be sure that our stuff works, but we can't buy the things or spend the time to get the things that will ensure that this works. And by spend the time, I mean level up our Grafana stack, which by the way is running on those boxes shoved into mysterious places. So it's like, all right, chicken and egg, what can we do about this? Well, we found out about a cool program from Datadog that will let you, as an open source project, as a nonprofit, get a free pro plan. So that's what we went with. Datadog has been really great for us to get metrics, logs, and traces from our web services like MeshDB and a couple of others that we've built since. It's also got great Kubernetes visibility tools and bare metal server monitoring, and it's got the alerting. So it's kind of this nice whole package that just abstracts away that observability for us and lets us do cool stuff like this. So a few months into running MeshDB, we noticed that we were having these big spikes in disk latency, and we were like, what the hell's going on, man? We saw these requests timing out, and we're like, all right, okay, so the requests are timing out in the front end. Let's take a look at the Kubernetes metrics. Okay, that should not be happening. There's a bunch of high disk ops on our Kubernetes nodes, but they're virtualized. So what's going on? Well, let's take a look at the lower stack at the bare metal, like the Proxmox layer. Oh, that's what's happening. Our disks are dying because they're 10 years old. Not so great. But Datadog let us figure stuff like that out. Another example, this is actually really small, so I'll just explain it. But basically, we were having this really flaky import job from GitHub, and we're like, what's going on? Maybe our code sucks. Actually, it turned out it was GitHub's fault. Their API was just 503ing us on every third request. So it was just a matter of increasing the retries and increasing the backoff until it worked. So that was the whole thing. So anyway, I want to take a quick sidebar here to say that you can also get Gratis Datadog if you are an open source project. Go to this link and fill out this form. And there's a couple of requirements that are elaborated on the website. But basically, the process is you submit this form, you sign up for a trial account, you do the trial, then they'll get in touch with you and they'll ask you a few questions. they'll ask you to do a few things. So first of all, you need to have a public-facing dashboard to show what you built with Datadog. And then also they'll ask for a blog post about how you use Datadog. And that's it. And then you have free pro plan for life, as long as the project is still up and being maintained. So yeah, this was really great for us. And it leads to my second lesson, which is do what lets you move fast. We didn't have the capacity, the volunteer capacity, to build a good observability stack for our web services. We didn't know what the hell we were doing. So we're like, all right, let's just go with this free thing. We already use Slack. We already use Google Drive. Like, the point is to give people internet. The point is not to, build cool software or whatever, right? So let's just let's do what gets us to that goal of giving people internet as quickly as possible. Sometimes you don't have the resources to do everything yourself. And even though that is something that is we like to do in the mesh, we like to try to self-host as much as possible and do as much as we can by ourselves. Sometimes that's just not possible. And if it weren't for Datadog and Google Drive and Gmail and Stripe, the mesh would look very different. We probably would not have finished MeshDB. It took 1.5 years of development. And yeah, I think that Datadog was a big factor for helping us finish that project. So anyway, do what lets you move fast. 2025, we get new hardware, we're self-hosting more stuff, we've got a reproducible IAC, we're teaching people new skills. Our stack looks like this. We've got these brand new R640s because we've managed to be like, hey, look, MeshDB is awesome. Let us get some new hardware to build some more stuff. So we get our R640s, they run Proxmox, and we give people access to this great work and play space. They can do whatever they want. They can build, they can experiment, they can learn. And on top of that, we also have Kubernetes to host our web services. That's great. We get this new IP Explorer, which further automates that troubleshooting process I was talking about, right? You can just go to this, you can just plug in an IP address on the mesh, and it'll tell you a bunch of stuff about the node right off the rip, and you don't have to go and log into the router and run a bunch of commands and all that crap. It's just right here, which is really great. We also get better OSPF event feed support. So now we can see in real time every single update that's happening. Before we could just see the state of OSPF, now we can see the events as they happen, which enables new projects like this flapping detector. So we imported those metrics from our OSPF stream into Grafana, and now we can detect flapping with this cool dashboard. So that's pretty sick. The final piece that I'll talk about, I think, is our automated alerting. So we're at this point now where we have a bunch of these systems, a bunch of these automated systems set up to actually send people Slack messages in dedicated channels, and people will actually see them and react to them. So a little bit about Slack bots. First of all, they're highly customizable, right? These are we have I think, gosh, 20 or more Slack bots built by completely different people. That's how easy it is to get set up with them, right? They've got great APIs, they've got great libraries. So you just get up, you go, you deploy your thing, you enable WebSocket mode, you're cooking. It's also very simple to set up and configure, like I said. There's also high visibility because Slack is our primary mode of communication. So everyone's watching, right? And when an alert drops in Slack, you can actually see it, which is great. However, this has not replaced our relationship with our members, right? People still feel empowered, and we work very hard to help people feel empowered to report issues and to help us diagnose issues. When you're an NYC Mesh member, you're a member, right? You should feel some sense of ownership over this network because you're the one enabling it, right? You set up a node and then you enable other people around you to get internet, which is really great. So having that relationship with your members, we found is really important because otherwise maybe they wouldn't tell us about stuff and then bad things would happen. But what I want to highlight here is my third lesson and final lesson is to lean into your users' workflows. Everything we've been doing has just been to get the people who are diagnosing and troubleshooting and fixing and debugging, get their information in front of them faster, right? I'm not trying to reinvent the universe and tell some of the volunteers who have been with the mesh since 2014 how to do their job. They know how to do their job. I'm just some 25-year-old who thinks that they know how to use Kubernetes. So I try to just build tools that let them do their job faster, right? They can get those all of these diagnostic steps done much more quickly because they just, instead of having to like log into this, that, and the other thing, they just go and look at a dashboard. So it turns a flow like this into one that looks more like this. And that's pretty awesome because they don't have to do as much work, right? Volunteer time is very valuable and very precious. And I'm very grateful that people are able to spend that time to help build this network because it's really sick. So anyway, in summary, build only what is obvious. That means that like if you as a sysadmin or a programmer or whatever want to build a tool or build a system, ask people what they need, right? Work with them, figure out what the requirements are, and build what they want, what they need. Do what lets you move fast. Sometimes you have to make compromises. Make those compromises. Get the thing out the door because you're not trying to build cool systems. You're trying to get people internet. Lean into your users' workflows, right? Get the hell out of their way, right? Don't like put this, that, and the other thing in front of them. Just like, or well, actually that contradicts. Anyway, you know, help make their work faster, right? That's what that means, right? Like let them do their thing and make whatever they're working with better. So okay, that's about all I had. It looks like we got about 5 minutes left for questions. Anybody got any questions about anything? Yeah, you in the back.
Like, I work in IoT devices, and one of the major things that I always want to learn from customers is unable to figure out if it's the router or the device is not allowing the data to go through.
Right.
And one of the things that, from the IoT side, the easiest thing was to use memfold. Like memfold is the solution you can use for IoT devices to just share, metrics and telemetry data information about your network.
Yeah.
So that helped a lot, but I always wondered, from a router side, from a mesh side, what is out there? Like I have
Arrow? Yeah.
Yeah, and then I can see all that stuff, but how far can it go to, really see that information?
Yeah.
Showed. And one of my questions is, when it comes to, let's say, like my example.
Yeah. We do have a microphone if you'd like it. I think we can just turn that on. There you go. Okay.
Thank you so much.
Yes.
Yeah. When it comes to being able to observe how the router is doing, the connections and all that, you mentioned using SNMP?
SNMP, yeah.
Is that something you had to configure custom-wise, or was that something you was just like a on and on switch and you can just point it to where it needed to send the information?
Yeah, so great question. SNMP is a pretty standard utility in like networking equipment. Usually you have to flip some kind of configuration setting on to have it do SNMP broadcasts. But then what we did for Zabbix, there is a built-in SNMP trap configuration. So what you do is you configure, I believe you configure a host, and then you can set up like an SNMP trap object, and it's like, hey, this IP address is going to send you SNMP data. And then it'll sort of just stream in, and you can configure it to auto-populate. We built a couple pieces of custom software around that to make it a little bit easier to actually automatically like set that up and configure it and like discover devices. But yeah, SNMP is like very standard. It's been around since like the 80s. I think we're on V3, but a lot of people still use V2. I won't get too much into it, but yeah, SNMP is a really good way to get all kinds of data from your network devices.
Cool. Thank you.
Sure. I saw you in the back first. Sorry.
To continue along the SNMP network stack
Totally.
questions. The stuff that you have, does it do NetFlow, SFlow?
NetFlow, SFlow. I'm actually not familiar with that.
So a lot of the router manufacturers and switches, they collect statistics and then feed like, bandwidth utilization and,
Okay.
record peer conversations so you can get like a holistic view of
Gotcha.
your traffic.
Interesting.
What's going where. It's great for like,
Yeah.
seeing whether your load balancing is working correctly and stuff like that. It's the, at enterprise scale, there's products like Riverbend or, Cisco. The protocol is called NetFlow from Cisco, and I think the vendors use SFlow or vice versa. But it's it runs on top of SNMP, but it's like a way to collect statistics.
Yeah.
I was just curious. Obviously, you don't know, so that's fine.
Cool. I will look that up, though. Thank you. And then here in the front, I saw a question. Yeah.
Take it away, Don Pardo. Great talk, Willard.
Thank you.
So, how has this work? Has this helped you in your technically in your day job? Has it helped you yet at an interview or outside of the technical in your day job? And finally, can you speak to the emotional benefits of this volunteer work?
Okay, sure. Yeah, so I'll say first, yes, absolutely. I've learned a lot of great skills doing this. It's funny. So at first, I would be working on a project for Mesh or working on a project at work, or and I'd like go to one or the other and be like, wait, hold on, I've been here before. I've done this. I like know this. So that's been really interesting. We use pretty much entirely Python, so I've gotten a lot of like really in-depth Python experience that has carried over to work. So that's great. I think your other question was about like interpersonal stuff.
No,
like,
specifically the emotional benefits from doing this.
Yeah. Yes, it's been very beneficial. I think it's a great project, and we try to spread the mesh as far as we can to help like everybody, not just people who can afford it, but people who can't afford it. I think that's like the particularly important audience for this is like in New York City. There's not a lot of vendors available in some areas, if at all, and if they are, a lot of households can't afford internet. So, we have like very heavy subsidies for them. They come basically from our donations. Like half of our members donate, half of them don't. So the people who do, they fund the renting of rack space, the leasing of fiber, the purchasing of equipment, the replacement of equipment, all of that for the people who can't afford it. And so, knowing that I'm like helping with that is pretty great. It's pretty awesome. So.
Awesome.
Yeah. Thanks. I see another question back here.
Yeah. Follow-up question regarding your volunteer work. There's a lot of folks that have the experience to help and volunteer, and I always wondered, from a tech perspective, where are these opportunities? Like there's places for volunteer, of course, like giving out food, helping clean.
Yeah.
But from a tech side, where do you recommend, potentially looking for someone like me or other folks that can help, on that tech side?
Yeah, another good question. So there are mesh networks all over the place, first of all. I'm aware of a mesh network in Seattle, one in Boston, one in Toronto. I think there's at least a couple in Texas. So, yeah.
8 or 9 years ago, some people actually were all here.
Totally.
Petered out.
Well, maybe you could start it back up again. That's always an option. There are also definitely technical positions available in other volunteer orgs. I know of a mutual aid group in New York City called Bushwick Ayuda Mutua, which needs technical people to maintain their support forms and their Airtable databases. And so they write code and maintain these databases for that organization. I'm actually getting into a project with them right now to sort of join their form to our form so that when somebody is like going through theirs and is like, yes, I want internet, it just whoop, submits a request to us automatically. So yeah, I think that like if you want to get more involved in tech for nonprofits, you just got to look for a group that's trying to do good work. Maybe like a local library or a bookstore, or look for like just meetups and just get involved and help out and just see what's needed, right? Like I wouldn't say like you should like push the technical stuff. Like if they need help elsewhere, maybe try that. But yeah, if you're like, hey, I want to get involved for tech, let them know, and they probably can connect you to resources. Yes, I can. Here's my final slide. You can check out my website at nilges.me. I'll put the slides on there. You can also email me at talks@nilges.me. That is not me, for your information. But then also, if you want to learn more about NYC Mesh, you can go to nycmesh.net, or please, I insist, join our Slack. We've got all kinds of cool information. If you're from New York City and want to get connected, join our Slack. If you're not from NYC and you want to know more, join our Slack. We're always happy to talk and collaborate. I also mentioned we have all of our stuff on GitHub. It's not on this slide, but it's github.com/nycmeshnet, all one word. Yeah, check us out. Are there any other questions? In the front? Where'd the mic go?
I can just say it really loud.
Okay.
First, as a comment, I really like your presentation style. This is something that clearly interests you and that you're very knowledgeable about.
Thank you.
I enjoyed watching it, even a second time. My question to you, though, is this is a great deal of information.
Yeah.
What you've just presented could easily be an executive summary of a whole team's worth of work, and there were likely other people besides you involved.
So
sure.
many. So many.
However, for one person to be able to sit in a position to present on all of that coherently is a great deal of work. How would you advise to others that they can use their position of doing to also better understand their surroundings and see places that they can help in the way that you've done with NYC Mesh?
Good question. Geez, I guess, first of all, if you already know people, just ask, right? I think that I would say never stop asking questions. Always be questioning what is this thing? Why do we do this thing? What could be better about this thing? What do you find frustrating about this thing? And slowly but surely the pieces will start to connect. Also, I really want to stress, if you're a tech person looking for tech volunteer work, also just get involved in the mission, right? I think that just doing the tech work is kind of dry. I think it's much more fun to go into the community and connect with the people that you're trying to help, or help organize, or help direct, or help manage. I think, honestly, volunteer orgs need a lot of managers. We have a lot of big projects that people have been gracious enough to take on, but without those people, they'd stagnate. So I think that organization is a really, really important piece of the puzzle, and you're only going to get to the point where you feel comfortable and confident with that by actually doing the thing first. So yeah, I guess take it one step at a time, and yeah, just work to sort of see that big picture and never stop asking questions. Does that answer your question?
It does. It
Okay.
sounds like you're saying be curious.
Yes, always, for sure, in everything, not just mesh, but also what's the chemical formula for XYZW? I don't know, but I'll go look it up later. All right, any other questions? One in the back here?
From your observation of altering NYC Mesh. Hi. From your observations of volunteering at NYC Mesh, have you noticed a change in, let's say, I guess, whether internet providers have actually started trying to provide services in areas that were not served?
Good question. I think the short answer is yes. I think FiOS in NYC has been getting better, more available. I think that's just going to continue to happen. NYC Mesh exists because in 2014 that was really not the case in a lot of places. You didn't have a choice, and if you even did have any internet at all, and it was usually pretty low service and very expensive, that's still the case in a lot of places. So yeah, I think it's getting better, but it's slow because building all this infrastructure is very expensive and very time consuming. Anybody who works in telecom will tell you that. And then even once it's there, on the consumer end, maybe it's prohibitive, right? It's either buy internet or buy food for a lot of people. So it's kind of a wash, but I think at large it's getting better.
WiMAX was supposed to solve it, but it never happened. There's a standard called WiMAX.
WiMAX. I think this rings a bell.
Never did.
Never happened.
So it did, but then, this seems like an excellent discussion for the after party.
Sure, yeah. I will mention, I think I'm the last talk in this room for the day, so maybe we wrap this up, unless anyone's got one more quick question. Otherwise, thank you guys so much for coming. I really appreciate it, and I hope you guys enjoy the after party. Thanks.